Hello viewers, in today's class we are going to discuss one important and conceptual problem from definite integrals involving greatest integer function, right? So here we have this problem, that is we have to find the integral of greatest integer of 1 minus x divided by x minus 1 from minus 1 to minus 2, right? So let us call this integral as I, right? And here see, in the integrand we have the greatest integer of 1 minus x, right? So what we will do, will here make use of the method of substitution, and we'll take t is equal to 1 minus x, right? So here we'll introduce a new parameter t, and we'll take t is equal to 1 minus x, so that x is equal to 1 minus t, right? And see, here the value of x varies from minus 1 to minus 2. So when x is minus 1, t is equal to 1 minus minus 1. So we have 1 plus 1, that is 2, right? So here we'll take x is equal to minus 1 to calculate the value of t, right? So similarly, when x is minus 2, the value of t is 1 minus minus 2. So this is 1 plus 2, that is 3, right? So when x varies from minus 1 to minus 2, t varies from 2 to 3. And see, here we have x is equal to 1 minus t. So if we differentiate both sides with respect to t, we have dx over dt is equal to 0 minus 1, that is minus 1. So dx is equal to minus dt, right? So now this integral can be rewritten as I is equal to t varies from 2 to 3, and for the greatest integer of 1 minus x we can write t. So here we have t, and in the denominator we have x minus 1. So we can replace this x by 1 minus t. So we have 1 minus t minus 1, and for dx we can write minus dt, right? So now we can write 2 to 3. Here we have greatest integer of t, and in the denominator this minus 1 and 1 get cancelled. We are left with minus t. Here we have minus dt. So this negative sign and this negative sign get cancelled. So we are left with 2 to 3 greatest integer of t divided by t and dt, right? So now here we have a greatest integer of t divided by t, and t varies from 2 to 3, right? So we know from the definition of greatest integer function, if t lies between 2 and 3, then the value of greatest integer of t is equal to 2, right? So here the lower limit is 2 and the upper limit is 3. So t lies between 2 and 3, and whatever be the value of t which lies between 2 and 3, the value of greatest integer of t is 2. For example, let's say if t is 2.2, then the value of greatest integer of 2.2 is 2, right? So now here we can replace this term by 2. So now our integral reads as 2 to 3, and here we have 2 divided by t and dt, right? We can take 2 outside the integral, so we have dt over t, and the integral of 1 over t is the log of t, right? And the limits are from 2 to 3. And now if we take the limits, and we'll take the difference, so we have log 3 minus log of 2. So this is 2 times log of 3 over 2, right? So here we have used the important property of logarithms, that is log m minus log n can be written as log m over n, right? So here we have 3 over 2, and if we use this property, that is a log b is equal to log of b raised to a, then I is equal to a log of 3 over 2 square, right? So we can write it as 3 square is 9, 2 square is 4. So the value of this integral is log of 9 over 4, right? So this is how we can solve these type of problems.